Universal Time.
I am in radio contact.
Okay, today in the lab it is a Keywest Technology 800 series video title generator. This particular one is used in analog TV stations as part of the Sage emergency alert system. So this generates the video overlay text that you see when an emergency alert comes on the screen. So what I have going on with this one is it's kind of hard to see on my screen, but here is a test pattern. It's putting a fair amount of noise in the picture. You can kind of see the black speckles that are going across the yellow field on this test pattern. Let me try a different pattern here. Hold on. Let's see if we can find something. Okay. How about on this black and white? So you can see on the most white bar there's sparklies in the picture. See what else we got here. That's an even better source. So I'm probably going to say that seems to be a power supply problem, but let's take a look at it. Okay, so we have under this metal plate probably a 20-25 watt rated power supply module. This is where it connects to the main board here. So usually what I do here is I just put a probe in the chassis like that, assuming it's chassis ground. Your luck may vary. And with our meter here, we'll go and check our voltages. So red is a 5-volt rail, and that looks good. Another 5. The blacks are ground. Orange is plus 12. Yellow is minus 12. Okay. So those look good, but what you want to do when you suspect a power supply issue is just go and put your meter on AC here, then see what it says. So I'll go and look at red again. So red, we hardly have any movement on when the meter is on AC. Same with the other red. Orange, which is plus 12. Hardly anything as well. So yellow with negative 12, we're showing 139 millivolts worth of ripple, and that should be fairly close to zero like the other rails were. So going to get the power supply module out and take a deeper look. And here with the lid off, we see the power supply module and how it's connected. Our AC input and ground on this side, the inner workings of the switch mode power supply, then the business end. Okay, with the power supply out of the chassis, I've done some investigating, and it looks like the 12-volt rail is regulated by this on semiconductor 7912. So this has been in operation for about 15 years. So I'm going to suspect that maybe one of these capacitors on the output of the 7912 regulator is starting to go bad, and maybe even the input capacitor, like this one here, may be a little bit bulgy, but I'll look at that. And I noticed these are actually Rubicon capacitors, and that's actually pretty good. Pretty surprising to see Rubicon on a power supply. Not quite sure who UMEC is, but that is who makes this power supply. So as you see, We're rated for plus 12 at an amp and a half, plus 5 at 3 amps, and negative 12 at 0.3 amps. So it is a 25 watt power supply. Got my soldering iron heated up, and I'll try to get the output capacitor out so we can take a better look. So what I'm going to do here is going to apply a little bit of solder and then bridge the contacts with the iron. Which that didn't work, so we need a little bit of grip on this capacitor to get her out. It might be wedged in there a little bit too good. Oh, it's coming. I'm actually getting caught on the screw of the regulator. And also, someone put some of that gummy snot in here as well. Okay. So we are out. And it looks like it is a 25 volt 100 microfarad cap. A moment while the cap tester comes out. Come on. Okay, so the 100 microfarad capacitor is currently reading at 55 microfarads. Okay, from the capacitor repository, I think I'm going to use this 100 microfarad 25 volt Panasonic part that is low ESR. Okay, so I'm going to use a Solidipult desoldering tool to clean the excess solder out of the holes so we can mount the new capacitor back on the board. Okay, remember when playing with electrolytic capacitors, always remember to put them in polarity correct. So on a new capacitor, the long lead is positive and the negative lead is marked on the case with a stripe like that. And on the board here, you'll see like a little indicator of negative in the pattern on the printed circuit board. There we are. I'll find some wire cutters. Trim our leads. Alright. Stick this back in the board and give it a try. Alright, we're going to run a little bit dangerously and keep the blast shield off for the time being. And, for power. The unit has come back on. We'll measure our voltage here. So our negative 12 rail is we are now at negative 12.17, and when we move the meter to AC, practically nothing. And all of the noise looks like it's now out of our picture. So yeah, like the one capacitor in the board that doesn't look like it's a Rubicon dried out with age and was no longer 100 microfarad. So that's all the time we have for today. As always, thank you for your time and try to enjoy yourselves the rest of the day.